Hello, my name is Yves Comeau, and I am a professor at Polytechnique Montreal, located in Montreal in the province of Quebec in Canada. I will start by introducing why it is important to remove phosphorus from wastewater. Eutrophication is a process in which an excessive amount of nutrients added to a water body results in excessive plant and algal growth. In freshwater environments, phosphorus is the limiting nutrient. In oceans, however, or marine environments, nitrogen, phosphorus, iron, or silicon can be this limiting nutrient depending on the environmental conditions. Thus, in freshwater environment, phosphorus removal is needed to control eutrophication. Here is an example of a cyanobacterial bloom in southern Quebec. Although cyanobacteria are not algae, they are often called blue-green algae, and we can nicely see why on this picture where the floating cyanobacteria are green and where the dried cyanobacteria on the shore become blue. In this specific watershed, pig manure applied on agricultural land is largely responsible for excess phosphorus accumulation in this 2-meter deep shallow bay of Lake Champlain. In freshwater, nitrogen sources come from upstream, but can also come from air, which contains approximately 80% of nitrogen gas. This nitrogen gas can be fixed by some bacteria, including photosynthetic cyanobacteria. Phosphorus, however, can only come from upstream of aquatic systems and marginally from atmospheric deposition, such as dust from Sahara Desert in Africa that has been shown to fertilize the Atlantic Ocean and the Amazon Basin in South America. Diffuse or non-point sources of phosphorus include mainly agricultural fields, which are best controlled by fertilization plants. Point sources include wastewater treatment plants, which contribute increasingly larger loadings over time. Phosphorus removal is best achieved by chemical and biological processes for such point sources. For the benefit of the environment, strict pre-removal regulations are needed. The trophic state of lakes can be characterized by their total phosphorus concentration, a general relationship established by Dr. Vollenweider. An oligotrophic lake would be nutrient poor with few plants and very clear water. An eutrophic lake, on the other hand, would be highly productive with lots of plants and algae and less clear water. A mesotrophic lake would be in between. The y-axis on this graph describes the probability of the trophic state of the lake according to its total phosphorus concentration. For example, a lake containing 100 microgram of total phosphorus per liter would have about 66% chance of being mesotrophic and 17% chance of being oligotrophic and 17% chance of being eutrophic. A typical desired target for environmental effluent discharge objective in freshwater after dilution is 10 microgram of total phosphorus per liter in the receiving water. Such a value would translate into a regulated discharge concentration that would typically vary between 100 and 1,000 microgram total phosphorus per liter, depending on the environmental conditions. And stricter or less strict values could be specified by environmental ministries, depending on a number of factors. I thank you for your attention concerning this introduction about why phosphorus removal from wastewater is important.